The state of a system, then, that is at equilibrium, can be specified by specifying three things: the temperature, the pressure, okay, and the phases present and the amount of each type of molecule or ion that's present in each phase. Because it's at thermal equilibrium, so its temperature is well defined. It's at mechanical equilibrium, so its pressure is well defined. And it's at material equilibrium, so its composition is well defined. If you specify all of those, you're specifying what's called the state of your system or the equilibrium state of your system. Okay? That's how you specify an equilibrium state. Now, we can make a system undergo a change from one equilibrium state to another by manipulating the surroundings or the boundary between the system and the surroundings. Basically, with this one, we can make change happen by disrupting thermal equilibrium, mechanical equilibrium, or material equilibrium. For example, okay, let's say you have a pot of water at room temperature. Okay, it's not doing anything. You're looking at it, it's fixed temperature, it's not changing its volume. So we say it's a thermal equilibrium, right? So mechanical equilibrium. How do we make that pot of water change? Well, you put it on a hot stove, you change the surroundings, so the surroundings is now hotter than the system. What will happen if you place something hot in contact with something cold? What happens to the pot of water if you put it on a hot stove? Temperature increases, right? So there's going to be a change in the water. By changing the surroundings of your water, you cause a change to occur in the water. The temperature goes up. What about you have an inflated balloon? What happens if you squeeze it? What are you doing? You're increasing the external pressure. And so by doing that, the wall between your system and the surrounding moves. Okay? What if you pour acid on a metal? Generally, your metal will react with the acid. A chemical reaction will occur. You're changing the environment of the metal. The metal might just be sitting on a bench top, not doing nothing. But if you change its surroundings, you put it in a beaker full of acid, a chemical reaction can occur. So you're altering you're causing a change in the state of your system. Right?